tenths to the nearest tenth, okay, so 27.0. So the nearest tenth would be one place after the decimal. Okay? Questions? Alright, so your assignment is page 324 to 325, numbers 1 through 19, God.
Odd. Oh, if you're trying to
Seriously?
no, I cannot.
Seriously, that's all.
Well, I mean, I already did like 1 through 10. So,
I love you.
oh my gosh.
Thank you for the corrections. I literally didn't have any. And I had my mom do it too. And she's like, this is a nice paper. It's just there's some like notes. Thank you. Yeah, it was really good. Thank you.
Thank you. Number one, it's like just pi 18. That's what I got. Well, do you want pi 18 or do you want like 56.548667776? Because it gives us the radius, which is 9. So if you're going to do pi times the diameter, you would have just pi
18
times
pi.
18 pi going on.
Alright.
Yep.
Great. That is
I saw that finally.
And I had a question on my test.
Thanks for brushing my hair.
I know. They are.
That's a big bother. Too close to me.
I took 2 points off my plate,
Oh, get me up your word.
but I would do it but that's
So
not
my
partial
calculus.
credit if I can see what
Oh, I think me and Lauren like came back and
that's
answered
what
that.
you're doing.
Oh yeah, we
Yeah,
did
me
some
too.
calculation.
Yeah.
Oh, the mine are all equal.
Yeah, they are.
Great.
You want to do it then?
I don't think I finished it. Or maybe I did, but I just wrote random stuff. That's not a good.
You're talking about your own hand?
Yeah.
Oh, I thought you said that so much. Not talking to me. My hands are always
Story.
It's hard.
That's hard to find.
I know.
These are such
Oh,
hard
yeah.
hands. Yeah, I
No, there's lots of holes in the bottom of my pants
Yeah.
all the time.
Yeah, I don't know how you do it with the uniform.
know. Yeah.
Like,
Wait, what are we talking about?
a lot of
How
places,
short my pants are.
a lot of places have longs now and stuff, but not like,
Yeah.
not with that.
These are the old versions, the old versions
Because
of
my
the
sweatpants
pants
are
before we
crushed
had
when
the
I use lights to my
online fancy.
Where's she with this?
Yeah, I heard to get like extra large so they'd be long enough.
Yeah,
but then they'd be like
that.
really
Yeah, and then they're super
Yeah,
wide.
like,
Yeah. Like Forever 21's pants are like, they're like, they grow out instead of down, so whenever.
Not a good place to
Mom-
shop.
They're like
You can
super
photo
short. And
Oh,
just
really?
super short.
I'm a person of Florida, and that's
Good
like
shot.
It's Thursday, that means it's almost
It's
Friday.
Let's not say that. The song.
I'm pretty sure I did this all wrong
not
because apparently they
Before I go, I like I did the phone and then I go here like
Alright, well, let me just tell you what the answers are and we'll check.
Well,
get
that's
them when I come out.
Number 1 is 0.69 meters per second.
I think that's right.
Number, well, I guess that's A.
Oh,
B
wait.
is 4.5 meters per second.
How did you see this? I don't know what I'm doing.
C is 5.3 meters per second. D is 4.2 meters per second. E is 1 meter per second. F is 5.5 meters per second.
Wait, Marnie, did you get
How'd
0.693
you
for
get
A?
E?
Yeah.
Not the
And
rest.
did you say that was right?
Yeah.
Okay.
I don't know. But I got E.
Cause that one was one of the more challenging of the
That's so weird.
one, or A I get, cause that one was more like the ones we did in class history.
See, I got this one, but I didn't get this one, this one, this one.
Mass 1 times B1.
Kind of made up my own recipe probably.
2.
But I don't know how I got that one.
Same thing, mass 1 B1.
Okay, you know how you did these separately over
We
here?
don't like
You have to do these separately over
you
here too.
multiply or wait.
So it has to be 10 times 6
Yeah.
plus 3
Like you
times
add
3.
the masses and then so
Okay,
you
equals
So I
3
do
times
that
9
for
plus
like
6.
all of these three.
Yeah, like how you have the right side separate.
Okay, these
Well,
are.
wait a minute. This shouldn't even be separate because they're moving together. But like this should be, they should be separate. That's good. And then you need to do the same thing on this side. But like these are moving together.
Yeah.
If they're moving together, there should be, it should be like 10 plus 3 times, so 13 B prime. Same for this, where they're moving together. You combine them, but if they're moving separate, then you do
So
it.
then both of these ones should be.
Did you
separate.
get
Yeah.
5 divided by 3 and then get 1?
Wait, for what one?
Whatever E.
I only got 3 divided by 3.
Yeah, me too.
This should be minus because it's going in the opposite direction.
Oh, like, are you looking at the, because for this one, since they're moving separate, they're not like touching, so they're not
And then
moving
for the
together.
other side,
You have to use both the separate, like 10 each and then 9
Switch.
because it gives you both of them for a
Wow.
second.
Because
Because it's like the before and the after.
That's how these pencils are.
Mm-hmm, yeah. And you're just solving.
You're getting it figured out.
Yeah, I made up my own equation, but I get it.
So you can get more eraser? Like, you like.
Instead of
I-
multiplying them, like this way,
There's,
I did add and add.
Okay.
I don't know, but I get it now.
What's the thought?
awesome.
Totally I'm smart. Supposed to add the velocities. I kept it sounding like it. I just want to get it over with.
Other questions about that?
We haven't asked her.
This side,
What do you do?
would it be?
Since they're together, you add them together. So it's
30.
yeah.
It wasn't even funny. I don't like that one. Did you say pop-up?
4.46.
I'll eat it, but it's not like I don't crave it like you do.
Alright. Go, we're going. I can pause. We're gonna do one more note. No more notes, we're done with notes. We're done with new material.
Deuces.
We're gonna do the multiple choice questions, and then we're gonna do the back of that worksheet.
I have a question.
Yes.
For letter C, I got 7 somehow.
Okay.
And I'm pretty sure that's right.
No, that's 3 plus. Sometimes
See, we didn't do much of
plus 3 times 3 equals.
Is it?
Put back on TV. I prefer teasing.
These are
with your
moving together,
Oh,
which you did the same thing in this one. Yeah, both of these are moving together, so you add the two masses together, should be 13 prime.
okay.
What is this one?
Any other questions about that?
Yes, it is.
Just there's another piece of lead in there.
Alright. A firecracker is at rest and has 0 momentum. What statement best describes the combined momentum of the fragments of the firecracker after the explosion? Everyone agree?
I don't think anybody has read it.
Sorry, I haven't looked at it.
Are we not ready yet? No. Just more than
You are
on
so
top
ready.
of it. Go, Lauren.
The math is.
Well, that's not five.
Yeah.
But that's a depressing.
I got it.
What do you guys think?
Is this the last thing we're gonna do?
Yes.
This
Not going
describes the
over.
combined momentum of the combined momentum.
The combined momentum is 0. The combined momentum is enormously large. The combined momentum is
Like
large
B.
but not enormous since it has very little mass. In some states it is illegally large. In other states it is legally large.
That sounds
That's
nice.
a bit sketch.
I think A seems the best.
A is the best. You're right. The combined momentum will be 0 because we talked about the momentum is conserved. It doesn't. Wouldn't think that it would have 0, but because of the direction, it would be. Alright, 2 pop cans are at rest. A firecracker is placed between the cans and lit. The firecracker explodes and exerts equal and opposite forces on the 2 cans, assuming the system of 2 cans to be isolated. The post-explosion momentum of the system. You can't read all of the answers. This is stupid. Alright, well, hopefully it's not B.
Is it A? No. B.
I think it's D.
What is D?
Yeah, it's D!
What
I was gonna say.
That's what I was thinking.
It should say something to the effect of, let's see, the post-explosion momentum would be 0 again, because,
Can you scroll it?
no, I
No?
tried, no, it won't go up, it will only go over. So, yeah, but that's what it probably said.
Gotcha.
What a great question. Okay, hopefully you can read all of those. Alright. 4 students of equal mass board large carts as shown. The students on cart A push off cart B. Oh, I have a thought. What if they just turn? No. Okay, sorry. How do the impulse and momentum change and velocity change of the 2 carts compare?
C.
Good. They will be the same. Cart A has 16 times the mass of cart B. The students on cart A push off cart B. How do the impulse, momentum change, and velocity change of the 2 carts compare? Are you looking at the circle bodies?
Yeah, they look so. It's so funny. Look at that. They look like spiders.
They're like 300.
B?
E.
Oh, I thought you said B.
What? Oh, okay. No.
The impulse and the momentum change will be the same for each,
Like it.
but the change in velocity will be greatest for cart B. Okay. A blue cart and a red cart with one half the mass are at rest. A spring-like plunger connects them. The springs are compressed and released. Which statement is true about this explosion? Explosion in italics.
I get confused because I want to say it's like 2 times difference because 1/2 less mass, but is always momentum always the same no matter what the mass?
The momentum of the system will be conserved. So the momentum change. This is talking about the momentum change of the two.
So is it the force that's always equal
Yes.
between the two, but not the momentum?
Right. But the momentum change. What would you say?
Still there.
Yes. So the momentum change is the same because the overall momentum is conserved. So if one is going, they would be opposite directions, but the amount that the momentum has changed will be the same.
So it's, okay.
But the momentum of the individual objects could be different depending on their mass and velocity. Okay. A blue cart and a red cart with 1/2 the mass are at rest. A spring-like plunger connects them. The springs are compressed and released. Which statement is true? So this time we're talking about the velocity change.
A. C? Oh, dang, those are different ones. Yay.
The velocity change of the red cart would be 2 times greater than the blue cart.
Technically, aren't they both pushed with the same amount of change?
They're pushed with the same amount of force, but if you weigh less, your velocity will change by more. Right? Because you would go faster if you weigh less. Okay. Why don't you guys do the back of your worksheet, and hopefully we'll have time to go over it for you. And let me know if you have questions. The equation, so to speak, will be similar to the equation that you were using on the test, if you used an equation. But the method would be similar.
Is this the one where you do like, so you use several different equations all the time, don't you? So like, is this,
For all of them, this is based on the momentum conservation equation.
so it would be like M1, V1,
Basically that.
M1 V1 plus M2 V2?
Which for number 2 is not going to be like that necessarily, because there's, I guess you could.
I feel like there's not enough information.
Could we set it up 2.1V equals 5 times 26?
Where's your 5?
The 2.1.
So 26 is the original speed, so that would be 2.9 times 26.
Because I thought we like would add.
You do, it is 5 after the fact, that's right.
Right.
But the 26 is the first velocity, not the post-collision
I
velocity.
meant,
That's what I had the,
So
together.
it's 2.9.
Like see this one. Someone's moving together. you
Times
combine.
26 plus 2.13 equals.
2.1 would be times 0, so you don't know that part. The brick isn't moving before.
Okay, that's right. So that would be 5 equals 5V.
Yeah.
where are you getting 5 from?
Adding 2.9, 2.9. Wait, 2.9 times 26 equals 5. Oh, okay. What?
How would you go?
Oh, maybe my calculator.
How did you get that? Did you get 10.9?
No. Oh, now I got 15.08.
Oh, you did 2.9 times 26 or 2.1?
0.9.
That's the difference.
Since you're.
Well, I typed it.